Hello everyone and welcome back. Now we're in example 1. And what do we have here? Well, it looks like we have two boxes, and those boxes are moving towards each other. Now that spring constant right there is going to be 10 kilonewtons per meter. The mass of box A is 15 kilograms, and it's not moving initially. The mass of box B is 10 kilograms, and it has a velocity of 15 meters per second to the left. What we'll see right here is these little latches, they're going to cause the boxes to couple together on impact. They're going to stick together as one body. What we want to know then is the maximum compression of the spring. So, how are we going to solve this? Well, I'll give you a plan. I'm going to let you try this one on your own. You've learned about the conservation of linear impulse momentum. I figure like the conservation of momentum is close enough to that you should have a good idea of how to solve this. So, what you're going to do is use the conservation of linear momentum to solve for that initial velocity after impact. We're saying after impact, but before the spring compresses, so it's like the instant that it touches. And then you're going to use your energy conservation to find the compression of the spring. Love these equations. They're amazing for so much physics. So I hope they help you. So as always, I'll give you a few seconds of my time and a few minutes of yours to try it out. Then come on back. So 3, 2, 1, 0, negative. Okay, I'm kidding. Let's go forward. And what we do? Well, first off, conservation of linear momentum. The sum of the momentum at the beginning is going to be equal to the sum of the momentum at the end. So only one of the particles, but boxes, had a momentum to begin with. And we're saying that left is negative. Afterwards, they couple together, so they're now one particle. And the velocity is going to be different. We don't know what that velocity is, but it's very likely to the left because that's negative, and so the side right here is going to have to be negative 2. And so what we get is that my velocity is going to be 6 meters per second to the left. 6 meters per second to the left. So, pretty nice here. Now, with that, this is going to, if I have a velocity and I have a mass, I've got momentum, but I've also got kinetic energy. So I can use my conservation of energy equation to solve and say, okay, I want to figure out how much that spring compresses. Initially, the spring isn't compressed. Afterwards, it's compressed some amount. Initially, I have a kinetic energy. Afterwards, I have no kinetic energy. And so if I plug all this in here, what I get after solving is that the max compression of that spring will be 0.3 meters. Okay, and that's it. So conservation of linear momentum, a very simple equation. Conservation of energy, not always so simple, but in this case, pretty simple equation, and you're done. I think it's just beautiful. I absolutely love it. You could maybe try to solve this using your kinematic equations, but I feel like it would be a nightmare, so I don't want to try it out. Either way, if you want to, go ahead. So thank you for listening. I think that's it for this example. It is. So I'll see you all next time as we jump into our next example. Have a wonderful day. Bye-bye.